So, hello everyone, myself Anjali Arya from MTech IT third year. Today I will be discussing my internal test second paper of data science. I will explain all the question answers in clear and simple way with quick justification. So let's start with the question number first. The question number first says that in Bayes theorem, P of A by B is equal to dash. So the answer is P of B P of A by B is equal to P of B by A dot P of A by P of B. In this question, we are asked for the formula used in Bayes theorem to calculate the conditional probability. The answer Bayes theorem defines conditional probability using prior and likelihood. It describes the it combines the likelihood prior and evidences. Let's move next toward the question number second. The 68, 95, and 99.7 rule describes the probability mass of the dash distribution. The answer is normal distribution. It is an empirical rule which is applied to normal distribution only because this rule explains how the data is spread around the mean. Now move towards the third question, which says that the metrics that measure uncertainty gained when replacing distribution A with B is called dash. So here in this question we are asked about the dissimilarity between two probability distributions. This is used in information theory to compare distribution. So the correct answer is Kullback-Leibler divergence. It is used because it quantifies information loss and it measures the differences between two probability distribution. Now let's move towards fourth question, which says that ridge regression uses an L penalty while Lasson's an L penalty. This question checks the knowledge of regularization technique. Ridge applies an L2 norm penalty while Lasso applies on L1 null penalty to reduce the overfitting. So the answer is L2 and L1. The next question is a model that performs well on training data but fails on unseen data suffers from dash. So the answer is overfitting. This describes a situation where the model memorized training data instead of learning patterns. This reduces the generalization ability. Data it memorizes training data but fails to generalize. Now move towards the next question. In logistic regression, coefficients are estimated using the dash likelihood function. Its answer is maximum. Logistic regression finds parameters that maximizes the likelihood of observed outcomes because the model chooses parameters that make observed data most probable. Moving towards the next question, that is question number 7. The hyperplane in SVM that maximizes distance between classes is called the dash margin hyperplane, and the answer is maximal. Its justification is that SVM aims to separate classes with the largest possible gap. The separating plane with maximum margin is called the maximal margin hyperplane. Now, next question is question number 8. In clustering, K means minimizes the within cluster sum of dash, and the answer is squares of distance. K means tries to group data by minimizing the total squared distance between points and their cluster centers. Moving towards question number 9, in PCA, the first principal component captures the maximum possible data dash, and the answer is variance. PCA identifies direction in which the data varies the most. The first component always captures the highest variance. Now the next question is question number 10, which says that CNS are effective for dash data while RNS are suitable for dash data, and the answer is image sequential. CNN works best with spatial and image data, while RNS handles sequential or time dependent data So the answer is image data and sequential data. Moving towards next question is Hadoop's fault tolerance distributed storage system is called dash, and the answer is HDFS. Its justification is that Hadoop stores data across multiple nodes using HDFS. HDFS stores data reliability across nodes. Moving towards next Moving towards question number 14, Python collection ensuring unique elements is called dash, and the answer is set. Its justification is that set automatically removes duplicates. Next question is question number 15, which is bootstrapping samples dash replacement. Bootstrap sampling allows and repetition in the sampling. Question number 16. Probability fair die roll twice sum is equal to 7, and the answer is 1 by 6. 6 favorable outcomes out of 36 total. Now let's move towards the section B, which is machine learning concept. In section B, we have matching type questions where column A contains machine learning concept and column B contains their definition and the explanation. Now let's start. Manhut distance correspond to the sum of absolute differences, which is k is equal to 1. Euclidean distance corresponds to the straight line distance, which is k is equal to 2. Pearson coefficient measures the correlation. Spearman coefficient is based on the ranks. L1 regularization shrinks some coefficient to 0, which is less so. L2 regularization shrinks all the coefficient proportionally, which is ridge. Ragging uses bootstraps samples. Boosting focuses on misclassified samples. Ridge regression uses penalty lambda by sum by beta square. Lasso regression uses penalty lambda by sum. Moving towards next question, which is question number 17, where binomial n is equal to 10, p is equal to 0.5 expected value. Here we have to calculate the expected mean value by putting the values of n which is equal to 10 and p is equal to 0.5. Mean of binomial distribution is equal to np. We have got the answer 5. Moving towards question number 18. If r square is equal to 0.8 and TSS is equal to 100, find the RSS. The formula for calculating RSS is equal to TSS 1 minus R square. By putting the value of R square, which is 0.8, and TSS value, which is 100, we have got the value, which is 20. Moving towards question number 19, which is in linear regression, gradient descent update rule uses the term dash for the weight update, which is derivative of j with respect to derivative of w, and the justification is weight is updated by subtracting learning rate times the gradient of the loss with respect to w. Moving towards next question, which is question number 20. For a normal 0, 1 distribution, what percentage of data lies between -2 and +2? And the answer is 95.54%. Approximately 95.4% of the data lies within -2 to +2 standard deviation in a standard normal derivation distribution. Moving towards question number 21. For For k-folds, cross-validation with k is equal to 5, each iteration uses what percentage of the data for training? It uses the 80 percentage of the data for the training. 4 out of 5 folds are used for the training, that is 80 percentage. Moving towards question number 22, compute precision if TP is equal to 40 and FP is equal to 10. Precision is equal to TP by TP plus FP, which is 40 by 40 plus 10, which is equal to 0.8. Moving towards question number 23. If recall is equal to 0.8 and precision is equal to 0.4, what is the F1 score? The formula for F1 score is equal to 2 into precision multiplied by recall by precision plus recall. Putting the values of the recall and precision in the given formula, we have got 2 into 0.4 multiplied by 0.8 by 0.4 plus 0.8, which is nearly equal to 0.533. Now question number 24. A model gives Tp is equal to 70, Tn is equal to 80, Fp is equal to 20, Fn is equal to 30. Now we have to calculate what is the accuracy. And the answer, the formula for the accuracy is Tp plus Tn by Tp plus Tn plus Fp plus Fn, which is the total of all the values. Putting this value in the given formula, 70 plus 80 by 200, which is equal to 0.75. Moving towards next question, which is question number 25, which says that for a Poisson lambda is equal to 3 distribution, what is the expected value? For a Poisson distribution, the mean is equal to the lambda value. So here the lambda value is given 3, so the mean will also be 3. Moving to next question 26. Write Python code to compute mean of list A is equal to 2, 4, 6, 8 using NumPy. We have given the list which is A is equal to 2, 4, 6, 8. We have to write the Python code for this question. Here the justification is that NumPy's mean function computes the arithmetic mean of array elements. Here the NumPy mean function is used, which is np dot mean of a. So we have to calculate the mean of all the values given in the question. Moving towards question number 27. Convert list 1, 2, 3 to a NumPy array. We need to convert a list to an array. np.array converts a Python list to a NumPy and into a NumPy array. It is a function and of NumPy np.array, which is 1, 2, 3, and using this formula we can convert a list into an array. Moving towards question number 28. Create a data frame from dictionary, which is a is equal to 1, 2 and b is equal to 3, 4 using pandas. pd.dataframe constructs a data frame from a dictionary of columns. pd.dataframe key a is equal to 1, 2 and b is equal to 3, 4. Moving towards question number 29, replace all missing values in data frame df with column mean. And the justification is fill na with df dot mean function replaces na nas by column wise mean. In place is equal to true updates df directly. And the answer is df dot fill na df dot mean comma in place is equal to true. Fill na is a function which is used to calculate the mean, and if it is true we have, and in place it is true. Question number 13. Display first 5 rows of data frame df df.head function. Justification: head function shows the first 5 rows by default for a data frame. Moving towards question number 21. Plot histogram of column height using matplotlib. Plot.hist df of height. Justification: plot.hist plots a histogram for the given data array. Question number 32. Apply one hot encoding to categorical column color. pd.get Dumis df color. Justification is that get Dumis converts a categorical column into a one hot encoded column. Question number 33. Compute correlation between two pandas columns x and y. df and its answer is dfx dot correlation dfy. Justification is correlation computes the CORR computes correlation Pearson by default between two series. Question number 34. Find unique elements in list using Python set. Answer is set A. Justification. Set removes the duplicates and keep unique elements. Moving towards question number 36, which says that create the DQ and append elements 1, comma 2, comma 3. Its a solution. Its answer will be from collection import DQ. DQ is equal to DQ 1, comma 2, comma 3. Its justification will be DQ from collections creates a double-ended queue. Initializing with 1, comma 2, comma 3 binds them. Now the next question is pop smallest element from heap. Heap PQ dot heap pop heap. Justification is heap pop removes and returns the smallest element from a main heap. Question number 38. Create numpy array of 0 of shape 3, comma 3. Answer will be np dot zeros 3, comma 3. Its justification is zeros 3, comma 3 creates a 3 into 3 array filled with 0. Moving towards question number 39. Converts a column date to date time type in pandas. Its answer is pd dot 2 2 dash date time df of date. Justification is pd dot 2 date time converts a string or object to a date or to a date time date type. Question number 14. Filter date data frame rows where column score is greater than 50. Answer is DF. DF of a score should be greater than 50. Justification is Boolean indexing selects rows where the condition on a score is true. Moving towards question number 41. No single ML algorithm performs best on all problems refers to which theorem? Its answer will be no free lunch theorem. Justification is it states that no single algorithm is best for all possible problems, which is no single algorithm, no single machine learning algorithm can perform best on all the problems. All the algorithms are suitable for certain conditions. The method, question number 42. The method that uses smaller training subsets repeatedly to estimate test error is called dash. And the answer is cross validation. Justification is cross validation repeatedly splits data into train or test to estimate generalization error. Moving towards question number 43. In KNN, runtime grows with big of n, where n is number of points and d is the dimension. Answer is big of n d. Justification: each prediction compares with all n points in d dimensions. Question number 44. Because of dimensionality affects algorithms that depends on dash matrices. And the answer will be distance matrix. Its justification is in high dimensions, distance measure become less informative. Moving towards question number 45. PCA transforms correlated features into dash component. Its answer will be uncorrelated components. Its justification will be PCA yields orthogonal uncorrelated principal components. Question number 46 says that the process of mapping words to numerical vectors in an LFP is known as word of dash. Answer will be embeddings. Justification is word embeddings represent words as dense numeric vectors. Moving towards question number 47. In a neural network, removing random neurons during training is called dash. It's called dropout. Its justification is dropout randomly disables neuron to reduce overfitting. Moving towards question number 48, which says that Sparks uses dash RDDs for fault tolerance, distributed data storage. Its answer will be resilient distributed dataset, RDDS. Justification will be RDDS are Spark's fundamental immutable distributed data structures. And the last format and the last question will be in Hadoop, yarn stand for yet another resource negotiator. Here, the word yarn is the resource management layer in Hadoop. Thank you for your listening.